In this video, we will go over the misconceptions in probability. Welcome back to my channel, Numerics with Nadia, and let's get into our lesson for today. If you guys haven't watched my last video on compound probability, the basics explained, I'll go ahead and tag that right here for you guys so you can watch it before today's lesson. Our lesson objectives for our video today are to identify and correct common misconceptions in probability, understand the difference between independent and dependent events, apply correct logic for compound events involving and or, and last but not least, recognize the fallacy and gambler's fallacy and similar flawed reasonings. Let's do a quick review of some key vocabulary before we get into the rest of our video. Our first term is probability. Probability is the likelihood that a particular event will occur. Then we have independent events. Two events are independent if the outcome of one does not affect the other. Dependent events are two events where the outcome of one does affect the other. Mutually exclusive are events that cannot happen at the same time. A sample space is all possible outcomes of a probability experiment. Theoretical probability is probability based on reasoning or calculation, not an experiment. And experimental probability is probability based on actual results from an experiment. So these are our key vocabulary words. Go ahead and write those down in your notebooks. And now let's get through two really important distinctions here. So independent versus dependent events. For independent events, for example, if we draw two cards with replacement, they would be independent events because when you reshuffle and we put the cards back in, the chances of picking any card is still the same. However, if you don't replace the card, that would be a dependent event because whatever card you pull first, that would affect the results of the rest of it. Now for mutually exclusive events, let's say we're rolling a die. Event A is rolling a number 2, event B is rolling a number 5. These events are mutually exclusive because they can't occur at the same time, right? You can't roll a 2 and a 5 at the same time, so those would be called mutually exclusive. Now let's get into a few common misconceptions with word problems. Misconception number 1 is the gambler's fallacy. So if something hasn't happened in a while, it's due to happen again soon. An example of this in a word problem would be a fair coin is flipped 6 times and lands on heads each time. What is the probability of it landing on tails next? So a lot of people will think, okay, well, it's flipped 6 times and it's landed on heads each time, so it'll probably not land on tails next time, right? But the probability is still just 50-50. 50% or 1 out of 2, right? The coin has no memory. So every single flip is independent. It does not matter that the coin was flipped on heads 6 times in a row. It could land equally on either heads or tails next time. So this is misconception number 1, and it's called the gambler's fallacy. So this is something to look out for. Now we'll move on to misconception number 2. Misconception number 2 is believing that all events are equally likely. So all outcomes must have the same chance just because they're different. An example of this would be a bag contains 5 red marbles and 1 blue marble. What's the probability of picking a red? Well, some people would say, okay, well, we have red marbles and blue marbles, so if we want a red one, probably 1 out of 2. However, that's not the case here because we have 5 red marbles. So the chances of picking a red marble would be 5 out of 6. Not 1 out of 2, because the events are not equally likely. So this is another misconception, something to look out for. Now we'll move on to our third misconception. Our third one is a very common one. It's confusing independent and dependent events. So if one thing happens, it doesn't matter what comes next, even if it's not replaced. So an example of this would be you draw a card from a deck and you don't replace it. Then you draw again. Are these events independent or dependent? Some people think it doesn't matter, right? We just drew one card. How would that affect the results of the other? Well, it does, because when we're drawing that one card, it's taking one of those possibilities out, and our next card depends on what we drew. If we draw a 3 of clubs, we're not going to draw another 3 of clubs because we've already drawn that. So the answer here is that would be dependent because the outcome of the first draw affects the second. Now we'll get into our fourth and final misconception. Misconception number 4 is misinterpreting language. For example, or versus and. So here it says rolling a 2 or a 3 means both must happen. So an example word problem would be, what is the probability of rolling a 2 or a 3 on a 6-sided die? So we have two separate events here, probability of rolling a 2 or the probability of rolling a 3. That means we would add up both of the events. So the probability of rolling a 2 on a die is 1 out of 6. Probability of rolling a 3 on a die is 1 out of 6. When we add those together, it would be 2 out of 6, which simplifies to 1/3. So this is another misconception to look out for. That wraps up our lesson for today. I hope you guys enjoyed today's video. These are important things to look out for when you guys are working on probability. Please like the video if you enjoyed it. Comment any questions or any other video topics you would like to see down below. Please subscribe if you haven't already. Share this video with a friend, and I will see you guys next time.